Hello everyone and welcome to RoboSlog. I am Shriff and let's get started. Today I'm going to show you a circuit that I've came up with. It's an idea of a dimmable LED circuit and you can use this in many ways you want. I'm just going to show you the circuit, the layout and the code for it, and rest is up to you that how can you use it. There are a few examples like you can use it as a table lamp, a bedside lamp, or in any of your projects to control the brightness. So what the idea is, basically there will be two push buttons, one LED, a buzzer, and an Arduino with 80 mega 328p microcontroller in it, and we are going to use those push buttons to increase or decrease the brightness of the LED, and we'll use the buzzer to indicate the user that the brightness is at full or at its low. Okay, so this is pretty much it. Let's get started. I want you to open your browser. As you can see, I'm using Linux Ubuntu 2010 LTS version, and I'm using Firefox. So it's not necessary that you should use Firefox. You can use Chrome, Opera, or Edge, anything you want. I'm going to use Firefox. So let's open your browser. Okay, now we are going to use Tinkercad. I've already mentioned about it. You have to open it, you have to sign in, and you're all good to go. I guess I've already signed in. Let's see. Okay, I'm already signed in. So I'm going to use the circuits, and I've already made the layouts for you so that we can save some time and really make the video short as possible. Let me switch it to full screen. Okay, so we are in. As you can see, what do we have here? These are components which we are going to use in this project. I have an Arduino Uno R3, a breadboard, two push buttons, one red LED. You can use any color you want. I'm going to use LED, red color, and I'm going to use a 330 ohm resistor for my LED. Two pieces, 10k resistor, 10 kilo ohm resistor for my push buttons to make it as a pull-up resistor. I'm going to tell you about it in my recording section. And this is the buzzer which we are going to use. So let's make up the circuit now, shall we? Okay, I'm going to do the connections now. Let's hook up our circuit first, and then I'm going to show you the code. So first let's ground it. You can skip it ahead if you don't want me to draw the circuit, but I really like to draw my circuits, and I really like them to be as beautiful as they can be. No? I'm going to use the red color code for this, and this ground pin I'm going to use. Yes, that's right. Use black for this, and the black is then shorted out with this row here, and I've got 5 volt plus DC voltage in this row. Now let's position our buttons first. I'm going to use the center trench for this. I'm going to use this resistor here, connect it to my terminal 1A like this. I'm going to use my second button like this, use the resistor. Okay, so this column is shorted, this column is shorted. We can use the plus 5 volt from this side, and the other plus 5 volt from this side. Okay, so what we have 5 volt plus output here going into this one, going from this into this and into the switch. So what the basic idea is, when there will be plus 5 volts across this one, as this switch is currently in open position, there will be no voltage drop across this, so it will read 5 volts. Now if you read 5 volts from an Arduino, you're going to read 1. Like if you will use digital read from any of the pins using this one, so you're going to read 1 from this. So this is what we call a pull-up resistor, and I'm going to use the output as my digital input into my Arduino right here. I'm going to color code it as a blue because it will show me the logic. Going to use the second button like this. You can always skip this part if you don't like it. Okay, now what we have to do, we have to ground the switch because the 5 volts coming this way, going through this, as it's open, it won't go through this right away, but as soon as we press the button, the 5 volt will come across this and go to the negative ground. Okay, let's hook it up. I'll code it as black, code it as black 2, and now what remains is our LED. We're going to use different port for our LED to shine up. This is our buzzer. Going to use it right here. Always remember that this buzzer has polarity, so you have to take a note about the polarity in it. This one is positive, this one is negative, so I'm going to hook it up to our any of the pins. Not any of the pins, sorry, we are going to use the pulse width modulation pin, this squiggly sign. So yep, I'm going to just the connections at 5. So as we are going to use the LED to control its brightness, what we are going to use, we are going to use analog write. So for the analog write purpose, we also have to use the pulse width modulation pins, the digital side. So what I'm going to do, take more wire from this side, and I will color code it as red here. Now what remains is grounding it. Ground it as you like, no prohibition in it. I just want my circuit to look good. And look at this. Okay. Oh, I missed the grounding part right here. Black. Okay. It looks neat. What do you say? Nice. So let me give you a recap. 5 volt in, 5 volt to the switch. Okay. 5 volt to the other switch. Nice. Then the ground. Nice. Ground. Okay. And the buzzer, it's grounded. It has been connected to which pin? 6th pin of the digital side, and 5th one is connected to the red LED. Okay, this is the anode side. Cathode side, remember it has polarity, so you have to remember that the long leg goes to the anode side, i.e. plus sign, and the short leg goes to the cathode side, i.e. negative sign. Okay, so this is pretty much it. There is nothing left. We are going to what? The coding part, the main task. Okay, so I want you to switch on your Arduino IDE real quick. I'm going to open mine and I want you to open yours too. Remember, I'm using Linux, so it's different from Windows PCs. Okay, my IDE is up. I urge you to save your sketch first before coding, so that you can always use Ctrl plus S button to save your sketch at any given point of your coding. Now I'm at the bare minimum. I'm going to remove this thing. I don't like it. Okay, so what we're going to do first is declare our variables. I'm going to use, let me just get my circuit right here so that I can look at the pins. Okay, can you see me? I hope. Let me check. Yep, can see. Okay, so what pins are we using? We are using 2, 3, 5 and 6. Namely, 2 is for button 1, 3 is for button 2, 5 is for the LED, and 6 is for our buzzer. Okay, going to declare my pins right here using int function. I'm going to use button 1 for my button first, which is it oh, sorry, which is it at pin 2. Okay, fair enough. int button 2 is at 3. int red LED is at 5, and int buzzer for buzz is at 6. Remember that these pins with squiggly sign can be used for analog write. Okay, I'm going to use other variables too, like delay, as a d time, which will be around 500 milliseconds. I'm also going to use LED brightness variable, where I can put the value of the brightness taken from the buttons and directly write it to the LED. So what shall it be? It shall be LED brightness. Fair enough. I'll declare it as 0 because at a first initialization of the code, I want my LED to be turned off completely. And what other pins are we going to use? I guess this is pretty much it. I'll declare it later if I feel like. Let's do our void setup. Let's do our pin mode. Pin mode. Button 1 will be as input. I'm going to copy this for ease. I'll just do button 2 as input. I'll use output for my R LED, which is my red LED. Okay, sorry, should be red LED. And then I'm going to use my buzzer output buzz for my buzzer. You can always use comments to remember what it is. I don't use it because it's not that much hard to remember, but you can definitely do that. It's a good practice, it's a good programming. You have to be a good programmer to think of it like that. Okay, so what else do we need? I guess this is it. Our red LED, our buzzer, and 2 switches. So what first task we have to do in our void loop is to read the button changes. So what I said earlier, these buttons will be behaving as a pull up resistor. That means At idle state, without pressing it, it should uh, print 1 by default, and while you press it, it should print 0. So let's see if it does or not. I guess I need another variable where we will be putting the state of our switch, which we can call button val1. I will not declare it because we are going to read from button 1 or button 2. For button 2, button val2. Okay, let's go to our void loop again. Now using button val1, we're going to read our button 1, button val1 is equals to digital right, okay, sorry, digital read button 1. Always remember that digital read has just one parameter from where you will read, semicolon. And for my ease, I'm going to copy it and paste it, button 2 and button val2. Button val stands for the button value or button state, whether it is being pressed or not. I'm going to read the state and put it in this string here. Okay, now we will see whether it prints or not. So to make our code look good, I'm going to declare another void, which will be as serial print b for button, and I'm going to declare my void serial print right here. Serial dot print button value button 1 value is I'm going to copy this again to code fast, and here I will just print button val1 So you ask why button val1? Because button val1 is the variable which holds the current state of my button, and I'm going to copy all of this to make my programming faster and print it again. So now what it will be, button 2 value is in button val2. Now remember, we have to give space, give indentation, and we have to use next line after every print. So I'm going to use serial print ln, and here I need just a space. Okay, let's see if we have coded it right. I'm going to verify it with this button. You can verify your code for errors. Let's see. Okay, give me an error at serial print ln. Oh, okay, there was a semicolon right there. No, oh, here too, at the double quote, sorry. Okay, compiling done. Happy little green color, and our code is good to go. Let's see if it prints the button states or not. So what I'm going to do, I'm going to copy all of this and paste it the code section here. Start simulation. I'm going to put on my serial monitor. Let's see if it prints or not. Okay, it's not printing. Why is that? It's not printing because we haven't started our serial monitor yet. So for that I have to begin my serial monitor. Serial dot begin with what baud rate? We're going to use trusty old 9600 baud rate, which should be sufficient. And also after every print I need a little delay, so I'm not going to use this delay, or we can use that delay also. So delay d time is 500 milliseconds. It will delay for 500 milliseconds and then read it again. So this way we can also avoid the button jumps, like when you press the button, whether it is being pressed correctly or not, and it gives like faster 010101 values. It will just filter it out. So let's see if it's correct. Compiling. Wait for the apple in green color. It's purple for my case. In Windows it's green. Okay, it's all good to go. I'm going to copy it and I'm going to paste it here. Let's see the simulation and the serial monitor. It prints. Okay, as you can see, button 1 value is 1, button 2 value is 1, and if I'm going to press the button 1, look at the value of button 1, it gets 0. If I leave it, it will become 1. So we can successfully read our buttons. I'm going to stop the simulation. I'm going back at our Arduino IDE and we are going to code it further now. So what do we want? We actually want to increase the brightness of this LED at our desired pace with button 1, and we want to decrease the brightness of the LED with the same pace with button 2. So we're going to use the void loop function, and at the very end, what do we want? We want to write the selected brightness to our pin, what is it, pin 5, which is our LED pin. So analog right R LED, so it's ELED again, pardon me. What? Out. Good. Sorry. Just going to write. Okay. So we can always correct our errors in our coding procedure. Now let's get to the coding section. Going to see if button 1 is pressed, it's going to give us the value 0. So if button 1 equals 0, what do we want? We want our LED brightness is equals to LED brightness plus 10. So notice I'm going to use 10 as a plus sign. I mean the increment value is 10. You can use 25, 50, 100 from 0 to 255 because analog write uses value from 0 to 255. You have to keep in mind that you should never exceed from 255 or decrease from to 0, and hence if button 1 is pressed, the LED brightness will be incremented to LED brightness plus 10. As our LED brightness has been initiated with 0, it will be 10 after one press, and then it will be analog written to R LED. And guess what my mistake was? I didn't say what value should it write to R LED. Now we are going to tell the Arduino that write the value of LED brightness to red LED. That's good. Okay, the LED brightness has LED in caps, and always remember your variables. I tend to forget them. That's not a good sign. LED brightness. Okay, I've made a mistake and I've corrected it pretty quickly. That's a good thing. You should appreciate me. Okay. Now, what if our button 2 is pressed? If button 2 is pressed as 0, then it should decrease the brightness. I'm going to copy it and I'm going to paste it for my convenience as -10. So it will decrease the value of LED brightness with -10. Now that's good. Now we have to warn the user if he is at 255 so that he should not exceed the analog write of 255 value. What we're going to use is if statement. If LED sorry, if LED brightness gets greater than 255, it will get into this loop and it will execute the following command: write LED brightness equals 255, and what we're going to warn the user using this buzzer. So what we're going to do, we're going to turn on the buzzer. For that, use digital try our buzzer pin, which is buzz, as high, wait for some time, which is our D time, which we declared above, and I've used capital I TIME. That's nice. And for my convenience, I'm going to copy this and paste it and just correct the value to low. So it will just like go high low high low high low, and which will generate a frequency and it will buzz with a melodious tone, of course. Now what if our LED brightness gets to 0 and below this? So we're going to declare that condition too. I'm going to copy it and I'm going to paste it. Okay, where my if? You see that there's an error here. We did not close with the curly braces. Okay. Let me make some corrections. Follow along with me, please. Going to be over soon. Write it as when our LED brightness it's below 0, write it as 0, and then digital write buzzer high and low, then delay time, then analog write the brightness to our red LED. Let's check it for errors. Okay, I can already see some errors. I haven't used semicolon here nor here because I copy pasted it. The error just copy pasted with me, and right here because I've copy pasted it, the error got copy pasted too. Okay, else looks neat. Let's verify. It's always good to verify. Oh, there's some error here. Okay, LED brightness right here too. I'm missing my semicolons too much. Happy little green color for Windows users and happy little purple color for Linux users. Okay, I'm going to select all, copy, and I'm going to paste it in the code section of the Tinkercad. Let's see if it works like we intended it to. And I'm going to now the moment of truth. Will it work? I'm going to press the button 1, which will increase the value. Keep your eyes at the red LED. Okay, it's not writing, I guess. Am I holding it correct? So were you able to guess my mistake? I used button 1 equals 0. So when button 1 is equals 0, it is incrementing the value, where I should be using button val 1 because I'm reading and saving the value of my button to button val. So let's make some corrections. Button val 1 and button val 2. Verify, going to the safe side. Okay, copy paste. Now let's see if it works. Hope so. It's printing 111. That's nice. Oh, you know what? I'm going to print another thing, which will be my current value of LED brightness. I'm going to print it right here. Serial dot print ln LED brightness, so that it will give me the value of LED brightness with every increment or decrement which we'll make with the buttons. Okay, I'm going to copy paste all the code to my code section of Tinkercad, and I'm going to run the simulation. My serial monitor is up, and as you can see, it's giving me 0 because I haven't pressed the button and we have initialized it at 0. So let's press it and see if it increments. Okay, it incremented and our LED is up. Let me reset it back. So the LED is off. So keep your eye on the LED. I'm going to press it now. You'll be able to see the increment in the serial monitor. See, it's 50, 60, 70, and the brightness is getting up, up, and up. It's 100, it's 110, it's 120, 30, 40, 60 now, it's 170, 200, moment of truth, 255. The buzzer should peak that I'm above. Okay, did you heard that? Wasn't a melodious sound, but I'm using a passive buzzer where you can use your active buzzer for good performance. Because Tinkercad doesn't have an active buzzer, I cannot use that. It will give me some bad chirping sound. Now it's at 255. If I'll increase it, it shouldn't, and it should give me some. All right, so you see that. Now I'm going to use my second button to decrease it, see if it decreases or not. Let's see. Boom, we are finally getting lesser and lesser value with every serial print and every cycle of our Arduino code. That's what we wanted, and finally the LED should turn dark and off, and it should give us a feedback. Okay, heard that? So this is it. We have made our code. We have made everything possible with this code which we intended. Now you can always use some other variables, some other parameters, and some other things with your code and circuit. It's up to you, it's up to the viewers, it's up to the innovators. Use my idea as much as you like, in any way you like, always for the good purpose. Now what you can make with this, because it's currently locked down, I cannot get the access to materials with which I can make a desk light or anything. I can show you the way. You can make it if you're watching it at the right time. So what you can do with this, you can use, idea is up for you to use it your way. Use it, comment it what you did with this, and I'll be happy to see it. And I'll see you in the next video. And I'm going to, well, I should have said it earlier, I'm going to use the name Arduino 102 Envision because I envied it and I showed it to you. You can use this idea to make anything you want. I'm going to put my code, the required materials, the required components, and the process in the post. You can see it for the details. I've tried to detail it in the video itself. but if you would like to read, it's all there. Use it. Happy learning. Shriff Masham signing out.